My today presentation is about direct preference optimization, a simple RL3 algorithm for training language model from preference. My name is Yusuf. Here you see the outline of the presentation. We start by definition and discussion, then continue with DPO Objective Function and how does DPO work. We present DPO variants and finally present the references. Okay, let's start with some basic definition. Direct preference optimization or DPO directly optimize a language model with respect to human preference. DPO use a theoretical preference model. What I mean by this, each entry has a prompt and two response, preferred response and dispreferred response, and the probability is associated with each one. Okay, so we can again restate DPU directly optimize the language model with respect to a theoretical preference model. Given a data set of human preference over model response, DPU can therefore optimize the policy using a simple binary cross entropy objective. Discussion. I talked about this diagram in the last video. If you haven't seen it, you can watch it. As you can see, uh, we have three main elements: frozen language model, trained language model, and a reward model. We have a KL divergence law that compute difference between two probability distribution. We added the output of the KL and output of the reward together to generate the final reward and then do optimization. Okay, what is the problem with this algorithm? This algorithm is presenting optimization with PPO, proximal policy optimization. First of all, we need to learn a reward model and then optimize it. This is computationally expensive. We need more efficient and cheaper solution. We need a way to don't we need a way to bypass this reward model. Okay, that's the idea of the DPO. DPO, we don't use a explicit reward model. We use the offline data set, and we directly optimize the policy with respect to this offline data set. In DPO, instead of the scale loss, we have a cross entropy loss. Okay, so we have a cross entropy loss, and we don't have this reward model. We have an implicit reward model. We have an offline data set. So in this way, we have hugely reduced the computational complexity of the algorithm because we are just using an offline data set and we are directly using the policy and we are bypassing the reward model. Another point is that mm, I would repeat, we have three language model. One of them is here, another one is here, another reward model. This method PPO is expensive. That's why we bypass the reward model and we use the implicit reward model to reduce the complexity. Okay, and DPO objective function, as I mentioned, data set of preference has three elements. One of them X is the prompt, and we have preferred and dispreferred response. Here you can see policy reformulation for DPU. You can find definition for each variable. You can see here definition of the variable. Okay, the objective is to improve or increase the probability of the preferred response generated with the policy model with respect to the reference policy and decrease the probability of the dispreferred response generated with policy with respect to the reference policy. We divide the policy with the reference policy as a point of regularization. Also, this beta, as you can find definition here, is a hyperparameter that controls the amount of divergence from the reference model. This sigma is the sigmoid function. It restrict the output between 0 and 1 and provide a probabilistic interpretation. Overall, the computation is averaged over the dataset and the final loss is computed. Okay, how does DPO work? Fine-tuning a language model via DPO consists of two steps and is easier than PPO. I think until now all of you agree with this point. We don't use the explicit reward model and we directly optimize the policy. Okay, we have two-step data collection and optimization. In data collection, we gather a preference data set with positive and negative selected pair of generation given a prompt. And in optimization step, we maximize the log likelihood of the DPO loss directly, as you can observe in this figure. Okay, so you can see there is no reward model here. We have hugely reduced the complexity, the computational complexity. DPO has some variants. The first variant is IPO. The other of IPO found the overfitting issue in DPO, and they add a regularization term to prevent overfitting. The other of KTO directly optimize the utility of the LLM generation instead of maximizing log likelihood. And in iterative DPO, combines rejection sampling with DPO. It adds a negative log likelihood to the objective of DPO. You can find the reference here. This is my main reference, and my second reference was the Medium blog. Uh, if you learned something from this presentation, please don't forget to like and subscribe. Thank you very much.